CIT 226, Data Integrity and Security, and we covered up to using conditions last time. Today we'll try to understand large-scale extraction. Now there are strategies presented so far in the chapter which were quite tedious as well and time-consuming, effective, and providing the intruders with the data necessary to extend their search once they'll get the basic information about the databases. An intruder begins understanding the data schema, and strategies presented can be combined to extract the data as much for the larger scale databases. The data could be about the tables, column names, table names, and the information which could be inside those tables. First step is to list accessible databases which are reachable, then find what kind of database is it. Then one or several can be targeted, tables and columns can be extracted. Statements that can be used to extract the table names are these, which are quite common for different databases. That's why they say that it's very important to know that which database is it. If it's SQL Server, there is a different statement for mySQL and Oracle, and they are quite common and available on the internet as well, which can be searched. Now once that's done, the second step is to obtain the table names. The approach is to find the tables that hold the numbers and names of the tables in particular database. For example, sys objects has the name of the tables holding the table information, that what is inside those tables. Statements, again, it's written, select name from systables in SQL Server. Then on mySQL is select the column name from the information schema tables. And for Oracle, it's saying that select the table name from all tables. Then they'll show how can we obtain the columns. Intruder can construct statements to extract the columns and the data from within the columns. Again, the schema for SQL Server is select name from sys columns. For mySQL, it's select column name from information schema. And for Oracle, it's saying that select column name from all tab columns. Advanced techniques are in order to filter. Filters are often used in web applications to identify and defer the injection. So, as we discussed earlier, that there are some known filters or techniques which are there when you are developing the web applications. You can use that in order to defer an injection. A complete list of those typical words or phrases or variables are there which could be searched from the internet, and if used in your programming best practices, you can avoid all these kind of SQL injections. Characteristics for filters is search for and block certain non-SQL injected characters. Methods used by intruders to evade and trick filters is encoding, changing characters from ASCII to different formats, for example, hex. ASCII characters are normal English that is plain text readable. If they'll change that, the browser will still intercept it and would be able to read if it's in hexadecimal. So instead of writing the words which could be filtered by web applications, they sometimes use the hex code instead of an ASCII code, so that the web application, if it's not holding any kind of exceptions, it would be executed on those databases. Case sensitivity, for example, instead of writing union, most of the applications are case sensitive, so if it's written in Word as union on the address bar, maybe it would be filtered. So they change the syntax in a way, not the syntax but the way they write it by uppercase and lowercase, so that it's not automatically detected by the systems. Or break it down into two words, or break it down into, or split the word into parts of it. For example, S plus ELE plus CT, it eventually it's the same meaning of it, but they are just splitting it in between. Using alternative, for example, case statements instead of if-then statements. If you want to reach a final destination as 4, so they can combine it like 2 plus 2, and then it would be equal to 4 instead of writing some numbers or typical things in the URL. Now, success and techniques previously described depends on the permissions to the user for which injection statements are being processed, depends the user and the account which is compromised, or how they are actually trying to gather the information from there. Privileges can be identified and increased if possible. Intruder must know which privileges are grantable on the system, must locate or view the privileges table. So in order to get the information of the privileges of all the users and what kind of permissions they have, there are again queries for that which would help you in pulling out the information, which is execp and then sp help protect null username, and from mySQL it's getting the privilege type from the grunt table and the information schema of the user privileges, and Oracle, as you can see, that it's getting all the user sys, role, table and column privileges by passing simple queries. Now, obtaining the passwords. User passwords are stored using non-reversible hash within the table. Privileges are needed to access the table. Since they are concerned about the data integrity and security, the passwords are not saved in the database in a clear text format. They are already always converted into a hexadecimal context so that it cannot be read easily. If somehow someone is trying to read the information inside the table, if it's in the hexadecimal format or in the hash format, the other person won't be able to decode the password. Again, there are tools available on the internet through which if you'll get a hash code and if you'll type the hash code, it can be easily decrypted using the online services. Some passwords are saved as text string, pose a great risk to the data integrity and can easily be extracted. Now, again, they are showing you some queries through which you can get the username and passwords which are saved on the database using the privileged accounts, and it would give you a complete detail about that. Now, obtaining the passwords, one method of obtaining higher privileges is tables that hold the password information requires higher privileges than normal, because there are different roles for the users who will be using the database. Except a few accounts, like if it's a normal user and he has the read-only permissions, he might not be able to get access to the tables which is maintaining the username and passwords. Now, obtaining the administrator privileges for vendors and version specific, so strategies greatly depends on what kind of database are you using, if it's SQL Server, mySQL or Oracle. Now, brute force attacks are usually used iterative trial and error technique using different possible combinations, and complexities depend on the information user is trying to obtain. More successful if much background knowledge is obtained prior to the attack, because they'll use brute force in order to break the passwords. But if your database is properly guarded and you have your intrusion protection systems working, it can easily detect that someone is trying for different username and passwords. Now, automated tools can be found online, greater for gathering the information. And then we have some built-in things in the SQL Server, which is open row set. Now, it allows the user to remotely connect to a database to retrieve the information as a different user. Credentials are required to log in remotely, must match these database. There is no timeout. That's the only problem in open row set, is that if someone is connected to that, there is no timeout, and if the user is connected, it would remain connected for a period of time. Intruder can use brute force strategies to obtain necessary credentials, because there is no timeout, there is no account lockout. So whoever had the access to that, he'll keep on trying with different username and passwords till he'll get the right password. Now, emails are most modern systems, or the database systems use email to alert the administrators. Now, databases will automatically generate an email that includes user password if lost or forgotten. So if you have lost the username or the password, and if you are requesting it, the database would send a query to the web server, and then it would trigger an email with a link that if you click on it, you can change the password, or it would redirect you to the page with the help of which you can enter new username and password in order to get the access. So attackers can create malicious code, redirect or copy the information which is sent from the database to the web server or to the clients outside. That information can be captured and provides a channel for escalating database privileges by obtaining the sensitive information. Now, there are ways through which we can defend the database system. Learn infrastructure weakness yourself. Use careful system monitoring and thoughtful action. Careful monitoring means you must observe the kind of traffic from where it's coming, usually during what hours you are getting a traffic. If the traffic is coming from a source which is quite strange, for example, if your organization is operating in United Kingdom only, and if it's getting all of a sudden traffic from other parts of the world, it means that someone is trying to gather some information. Now, then combine the different strategies to create a strong defense. Now, we have different bound parameters or placeholders for binding user input, so that whenever the user input is entered in the fields, it does not go to the database as the information is entered or passed on through the text fields. Once the user input is bounded, it's placed into a pre-constructed SQL statement. Dynamic SQL is not necessary. User data is treated as user data alone, cannot affect the SQL statement. And then very effective defense can only be used for variables which hold data values. So it would convert it before sending it to the database, and it would see that if it's a common kind of injection which is being passed on through the browser or through the text fields, it would detect it over there and would cancel it before it can reach the database. Now, sanitizing the data is word blocking certain keywords that are not allowed as the input within the web application. As I told you, that all the common words or the list of keywords can be found on the internet which are recently found or which are quite famous for SQL injections. You can simply import those while constructing or while writing your own application or web application in order to protect it for any future possible SQL injections. Now, word filtering, balance the blocking the known keywords and identifying allowed keywords. Limit or mask the data fields to only those words or characters that should be used as input. As if in the username field you are not accepting any numbers, it should be defined in the application level itself that if something is tried from that field, directly raise a flag or cancel the transactions. Restricting and segregating databases means that assigning privileges on the database with greatest granularity available. Greater granularity available. Do not overlook permissions of the users on the web server. Injections are processed with web application privileges. Web server should have most restricted privileges because web server and database should be segregated. It's not like you have a web server running and you have the database running on the same server as well. In case if your web server would be compromised, your database would be compromised as well. That's why they segregate it into different machines. In one machine that would be dedicated for the database server, the other one would be dedicated for the web applications. In that way, the teams for the web applications would be looking closely on the web server, whereas the team of the database administrators would be focused on securing the database so that it's not compromised. Now, the security conscious database design that the infrastructure, we're designing the infrastructure is important when it comes to the security of the database. Consider where things are stored and how it is viewed outside the organization. So when you are defining the policies, you must think yourself as an outsider and how the information is displayed to the people who are from outside the network. Consider how objects are named and what information is given away. Change the default names on sensitive data. Do not use objects, views, and critical database objects. And create a honeypot environment, fake environment that intruders can find it interesting, and they'll try to come up to that machine in order to gather the information. Now, first of all, we changed the default username and the table's name and the typical syntax for any databases which is used, so that if someone is trying to know the table names or the syntax of the tables itself or the overall schema of the database, you can define your own standard and you can follow it along depending on the different departments within an organization. Now, honeypot is very important, where it's a lookalike normal working database with fake data inside and with least privileges available on the network. Now, what people would do is they'll think that it's the actual database. They'll come, or they would try to use different techniques for SQL injection in order to gather the information, and whoever is trying on those databases, complete log and details of the users is being monitored, so they can find out that who are the persons within the organization or from outside the organization who are trying to gain access to the databases in any specific organization. Now, diligent monitoring is it's equally as important as other security techniques. Tracking the errors can show indicators of a real-time attacks. That what's happening on the database, who's accessing it, from which accounts, what are the privileges levels, which tables are being accessed, what information is being regged out, what information was copied, what information was extracted or downloaded from the database. Now, tracking the resources usage can uncover the attack using the automated tools. Database requires per minute, or the database queries per minute, or the database request per minute, that if they are using any automated tools remotely to execute the commands in order to get the information outside the database, how many requests are coming. So, because humanly, if someone is trying many different queries in a minute or 5 minutes, and you know it that humanly it's not possible to pass those parameters, it is obvious in that case that they are using a tool or a bot in order to try different queries to find the information that they are looking for. Use baselines to create the threshold for the alert. So if it's exceeding those limits, it would send you an alert that someone is trying to do certain things on the database. Okay, that brings us to the end of chapter number 8.